Okay, guys, let's start the lecture. Right, yeah, again, I appreciate you come here in time, right? Because, this is the best way you respect your teammates, right? Respect your teacher, and also save us the time, right? Okay. So anyway, if you cannot come in time, I totally understand. So I record a lecture for you, and then I send you the lecture, right? Okay. So first, let's come back to this assignment, right? And then I just talk with you guys, right? And then it seems that so if you Amanda, right, is the one get the highest, right? Highest by GPA, BMI, okay. So hopefully you get the same result. If not, please let me know. Or again, if you have issue to get your program running, and then and just let me know. I could help you. Okay. So this is more about chapter 2, right? Chapter 1 is more introduction, right? Chapter 2 is more R, right? Okay. So before I move on, I will say tomorrow, right on here. So tomorrow, please come in time, because tomorrow I going to announce, right? Remember the category, right? Remember. So tomorrow, again, I still waiting, yeah, for the final. Some of you, like so anyway, tomorrow I will announce who going to in charge which category of data. Okay, and tomorrow I also will going to show you how to extract the data. Understand? So therefore, it won't take too much time. I think for me, it took me around 1 hour, 1 hour, 2 hour. I just copy and paste from the website and get it from the Excel file, and then to put the data together. So tomorrow, at the beginning of tomorrow, I will announce who going to in charge which category. Okay, and then I'm going to show you how to extract the data and put them into only one CSV file, right? And then in the next week, I think we should get everything done, the training done by Wednesday, and then on Wednesday you could analyze your data, right? And then on Thursday you continue analyzing data, and then Friday you get all the result, and then you write the paper, and then you make the presentation. How about that? Okay, this is the plan. Okay, again, so first I also want to talk about the literature review. Let me show you here. So literature review, again, you're going to get the paper, right? So hopefully you, as I mentioned to you here are the papers you're going to handle, right? And then, and for the writing, look, for the writing, I did find some of you, right? Which one? Who input this one here?
I did.
Ricky, very good, right? So Ricky, so I want to say, hey,
that wasn't mine.
So it's not.
No, I didn't do that.
You did not do that. So who put it here?
That was me.
Okay, Jason. Very good. Anyway, great, right? So so that's good. And but again, so Jason, you put the author here. That's great, right? And another thing I want you to do is I want you to put the paper here in the algebra order, right? B is B in front of L, right? And then put the titles of the paper. Okay, right? Because at the end, I want to use a program, a software to put all the references together. You understand? We don't, and then in that way, we don't have to tie. For example, when we submit paper, people are going to use 1, for example, and 2, something like that, right? Okay. So we have to put them for index for each paper. Okay. And because sometimes we're going to add some paper or delete some paper, right? So we don't want to do that again, because the sequence will be changed, right? Okay, because we changed the paper. So therefore, I would like you to put the title. Look, this is the author, the first name, the last name of the first author, and the year, and then the title of the paper. That's it, right? So great, right? So thanks for your work, okay, and registration. And then, but again, I would like you to give me the title of paper, right? Okay, good. And also, I maybe I think maybe you could maybe you could use different color, right? Okay. So for example, Jason, you could use a red color, right? Kathleen, you use green color. More one maybe use blue color, right? Ricky maybe use green color, right? And Kevin maybe use cyan color, right? So each of you using different colors, okay? And also like so Sarah and maybe Angie, we can talk about that, the colorful them, right? Anyway, I would like you to use a different colors and then just show your contribution, right, in the writing the paper. So finally, I want to let you know, right, after we put the paper together and after you make presentation, I will going to ask you to vote. This is anonymous voting, okay? So you're gonna vote who's number one author, who's the second author, who's the third author, you know, understand? And after that, I combine all the voting together. And then I tell you who the number one, who number two, who number three, right? And after that, the top three author, you're gonna continue working on revising the paper, understand? Again, all of you have to contribute to in writing the whole paper at the beginning. But however, I understand, right? Some of you very busy, right? And then you have your job to do, right? And then I would say maybe the top three or top four authors gonna spend more time revising the paper, and then after that, and again, I will help you. Finally, I want to revise the paper, and then I'm going to submit the paper. Understand? Okay. Good. Any question about the paper writing? Okay, good. So again, right, when you have time, it's not too late to start working on the writing. Okay, read the A papers I send you, right, and cite the relevant sentences, or right, write them and put them in the paper. Understand? And finally, we're going to right, combine them together, right, for the literature review. Okay. Good. Okay, so this is more about the assignment. All right, I think we're done. So today we start to working on chapter 3. So again, this chapter I want to show you the big picture, right? This chapter is more, again, this right, the last chapter is more about R and coding, right? And this chapter is more about data analysis. Okay, so for example, hey, look here, all of this, right? This distribution, okay, and then this all can show which, for example, distribution, just like I will show later. Distribution means, right? For example, right? The age, okay. For example, you had the age, okay, and then you could see the population for different age, right? Something like that, okay. This is called distribution, okay. And then this tool is very important here. You're going to use this, okay. This is going to tell, right, and to determine which factor, right, are important for vaccination decision, okay, understand? And then this one, look, these two show the similarity. So how similar, right? How similar, right, between different groups of population. Okay, so for example, we had, right, we had the age, right, 18, 25, you know what I mean? So we have all this kind of data, right, for different age, right? And then now I want to show how similar they are. For example, the age 18 is similar to the age and 25, you know, okay. And then I give you example here, this example, okay. So all of this you could use, okay. You could use all of this in your project. Understand? Again, this one t-test is very challenging, and ANOVA is challenging. Okay, I believe after the training, you know how to use it. You know how to use them. Okay, but however, I do want to introduce more detail. Right, what is the fundamental equation? What is the fundamental theory behind those commands? Right. Again, you try to understand. Even you don't understand, it's still okay because I believe you know how to use it. Understand? Right? So all this actually is graduate student level or senior college students level. Okay. Right? Okay. After you learn this chapter and you are at those level, right? You're kind of a senior college student or you are entry level graduate student, right? Understand? Okay. Okay, now let me just show you. So first I want to show you there's two types of statistical learning. Again, if then you go to the conference presentation, right? So there are two types. Okay. The first type is we call unsupervised. Okay. Unsupervised learning. And the second one we call, right, supervised. This is U, okay, SU. This is D here, supervised. Again, anyone know run this before, supervised and unsupervised learning? No. So unsupervised learning means what? Means just, hey, we have the data, right? For example, we have age 18, age 25, right? For example, I just make this up, right? It may not right. Age, I don't remember the last one. I say what? It's 40. Yeah, but anyway, and unsupervised means what? Means we're gonna find the relationship. Okay. Determine the relationship. Okay. Right. Between those factors. Okay. Right. So this is more about unsupervised. Supervised means what? Supervised means what? Means we had a, for example, we had a vaccination, right? For example, vaccination equal to for example, C is a constant, C0 is constant, C1 times, right, the number of age 18 plus C2 times the number of age 25 plus C3 times age, I just made this up, right? 80, right? 40. So look here. So the supervised means what? Supervised means we had an output, right? We had an output. Okay. So we're gonna predict the output. Okay, so this for example, age 18, 25, and all of them, they are input. Okay. This input, all of them are input. Okay, so supervised means what? The key point here, supervised means we had the output. Okay. Unsupervised means there's no output. It doesn't matter, right? Okay. Whether there's output or not, we just want to study the relationship between those variables, right? Okay. Understand? So in this project, we mainly focus on unsupervised. Okay. Right. Okay. So in again, we don't predict the vaccination number. Okay. We had a data, we had the vaccination for age 18, we had vaccination for age 25, we had the vaccination data for age 40, and then we use this vaccination data and to see how similar those people from different ages, right? And in their decision to get the vaccine or not, right? Okay, understand? So we don't predict the number of vaccination based on the age. Okay. Actually, it's very difficult to do that. Okay. Okay. Now let me. Hopefully you understand. Right. Again, this is a little bit challenging, right? But the difference between supervised and unsupervised. Any question on this? Okay. Now let's play a little bit around, like distribution. Okay. Again, in the program I show you before, let me see. Okay, I will talk about that later. Okay, distribution, you're going to use this one in your project. Okay, distribution. Right. For example, I would like you to show me, right, the distribution, right, of the age, right, okay, and how, for example, how many percentage people in the age of like 40 and 25 and 80, right? But anyway, 18. Okay, now let me just show you what distribution means. Look, we use this example, right? So we get the data, all right, for the students, okay, and then we see all these variables, right? Okay, distribution means what? We want to see, look, we want to see the distribution for the students' math score, right? Look here, and then you can see here, and look, the Y means what? We call frequency. This means the number of students, okay? Or sometimes we call it the number of samples. One student have one samples, okay? So the Y, it means the number of students, and then the X is the, look, we have the interval, right? This, look, this interval 1, right? Again, the interval is 10, right? From 50 to 60, and then this interval, right? So these are the intervals, okay? So distribution means we divide the scores into, for example, 1, 2, 3, 4, 5 interval. Again, you can specify the intervals, but typically the program help you to determine the intervals, okay? And then this one, look here, 1 means what? Means this one student, okay? One student. So we have one student with a score between 50 and 60. And then we have two students, right, with a score between 60 and 70. Understand? And then for the interval 70 and 80, we have 3 students. Right? And similarly, from between 80 and 90, we have 3 students. And then from between 90 and 100, we only have 1 student. Right? Okay. So we call this as a distribution, right? If you put them together, you leave them together, look, there's envelopes like this, right? Okay. Distribution, like you pass the middle point of the interval, right? The middle point. Okay. Understand? So you understand what's interval, right? What's the distribution? So another here. Distribution means what? Means the number of samples, okay, among in different, right, intervals, right? Okay, so sometimes we also call sometimes we also call right? Population, different population, right? For example, different age groups, populations, or sometimes we call groups. Sometimes we call categories, okay? Right, okay. So in this case, it's different, right? Different score, right? For example, different, right? Groups of students with, right? With the different scores, understand? So when you write your program, right? I say after you get the data, I think you could play around, right? Okay, for different interval, right? Understand? Okay, now let me just show you the program. The program actually is very straightforward. The command you're going to use is called HIST. This we call HIST. Actually, we call histogram. Okay. Histogram. Okay. Histogram actually is one way, one form of a distribution. Understand? Okay. Right. Okay. So now let me just show you. And then again, when you have your own data, you could play around. Okay. Let me just open the R. Okay. So now because I'm done with chapter 2, so I'm gonna open a new program. Right. I've opened a new program. Okay. I open a new program. Say R, and then I will say save it as right main. For example, data analysis. Right. Actually, this chapter. Right. Chapter 3. Okay, understand? Again, you put any name, right? In for the file. Now let's just write the program. Again, right? In case you close the computer, you should, right? You should right? Reset. Right? Remember, after you close the computer, you should look here, right? Go to the folder. Go to the folder. You save your data, right? For example, here, and then after that, you're going to use what? Right here, set as working directory, right? Understand? Otherwise, you can't find the data, right? Because in this case, we're going to use the student information, right? Student info here, right? Understand? Okay, now let's type the program together. I would say student. Again, you could copy the paste from the last example, but I would just type it. Student. Again, as I mentioned, like you just use equal sign here from now on. Equal sign. Okay. So students equal read table, right? And then again, student, the type, the file's name, student info CSV. And then again, we had the header, right? Equal to true. Just we could put T the same as the true, right? And then after that, you're going to separate by, right? Separate by comma, right? So we're done with the data. Again, I just want to make sure that I have the data, so I put names, right? Student, right? Okay. And after that, I will say I'm going to put histogram. So again, I just focus on the student. Okay. I focus on the category of, look here, the math, right? Okay. Again, you can control the color of the bar in the distribution. Like for example, I put the color as pink, right? And then again, I could put as label. I don't put y label. Actually, I should put y label, but the variable actually it just show frequency. Okay. So, but again, you could change your label, but I just don't change it, right? Okay, understand? Okay. Right. Okay, now let me just run the program. We go to plug, right? Okay. I run the program, select the programs. Okay. I run it. Okay, this is what I have, right? You should get similar result, right? Here. Okay. So how about this? Can you I just want to give you a chance to practice, right? Can you again like can you get the distribution for the chemistry score? Can I try? Try to get this histogram for chemistry. Anyone had issue to get it? So how can we change? Anyone can show me how can we change program? For chemistry, how can we change it?
Change math in the hist command to chemistry.
Very good. So we get to show chemistry, right? Student, just click chemistry here, right? And then you run it. And then you get a result. Look, this result, right? Right. Okay. Thank you, right? Jason. Good. Okay. So this is histogram again. So again, when you do a project, right? Yeah. So when you do the project, I will have some work for you to do. Okay. I will ask you to do something, but however, on top of them, you could do anything else you want instead. Understand? Right? For example, you could get a histogram, right? Okay. Now let's move on. So this histogram. Again, I want to give you a bit more detail of distribution, okay? Because we're gonna use distribution, right? When we do the right, to compare right, and when we made a decision whether a factor is important or not, right? Okay, distribution. Anyone learned distribution before? Great. Yeah. So we have Kevin, you learned distribution. That's great. So so the most common distribution we call normal distribution. Okay, this is the right, the most right, common distribution, right, seen in nature. Okay, now I just want to show you what the distribution look like here. Look, okay, this is the normal distribution. Right, for example, if you measure the weight of the Americans, right, and then you get if you plot the population, right, of the Americans, right, in different interval of the weight, okay, you will get similar profile, right? Or the weight, the height, right, and all kind of these features, right? If you get enough sample and then you plot the distribution, it look like this, okay? Understand? So we call it, this is Gaussian distribution, or sometimes we call normal distribution, right? Okay. Now, so the distribution, look, the most important parameters here, all right, I want to show you this mu and this sigma square. So mu actually is the mean value. Okay. And then sigma we call standard deviation. Okay. And then sigma square. Anyone know what sigma square? It's variance. Yeah. So this is variance. Okay. So the square of the standard deviation is variance, right? Okay. And right, I'll write down here. So this equal to the square of standard deviation. Okay, good. So now we call this as look here. Please, is right pretty complicated, right? Okay, this is we call this a probability density function. Okay, for the normal distribution. And then if you plot it, and then you look like this. Okay. Okay, so before I show you what this means, I want to show you the impact. So the impact, right from the mu the mean value and the standard deviation sigma on the distribution. Okay. So look. So for example, look, the green color one, right? The mu. Let me write down here. The mu as the mean value, right? Is the location. The location of the peak in the distribution, right? Okay, so for example, hey, this is the mu, right, for the green color, and this is the blue color. This is the mu, right, for the blue color. Understand? So the mu can change what, right? So this is mu. For example, this is mu equal to -2, right? This is mu equal to 0, right? So you can see the mu is important because the mu determines the location, right, of the peak value, right? The peak means that's the most common value. Okay. For example, if you do a sampling, if you just sample for the blue color, for the green color one, and the most common, for example, value you could get is -2. Okay. This is means this is the most, right? Right, the most possible value, maybe like that. Okay, most possible value for sampling. Okay, for example, you just sample, right, the value, and then mu equal to number 2 and equal to -2 is the most relevant, right? Understand? So so the mu determines the peak location, right? And now let me just show you what's the sigma. Sigma square. Look here. This one we have 3 different value, right? So for this 3, the blue, the red, and then the yellow, we have similar mu value. So the mu is the same, right? The mu is the same. So what do you see the difference between them? Right? Look, the blue carbon, right? The sigma square equal to 0.2, and then the red carbon sigma square equal to 1.0, and then the yellow one equal to 5.0. Look. So you can see, hey, the sigma square means what? Anyone can tell me what's the physical meaning? Can determine the how wide, right, the distribution can spread. Understand? Right?
Is it the amount of people in the distribution?
Yeah, you could say the range of the people in the distribution, right? Okay, the most popular range of the people in the distribution. Okay, let me write down here. So thanks, like this means write down here. I just want to say, hey, if this is smaller, look here, right? If the mu, the sigma square equal to 0.2 is smaller, right? And then you can see the range is smaller. Understand? Understand? And then if sigma is large, 5, and then the range is small, right? Okay, understand? So this means smaller means the value, like the population, right, and change in a smaller, right, range. Okay, and then means the population, for example, the people are not that different, okay, because they're in a very similar range, right? Understand? Because the range is very small, and then the people in that range, right, okay, have a similar value, right? So this means less uncertain. Okay. Understand? And especially this means what? More sure, right? About the estimation. Okay. So for example, right, again, I did not show that in my hand now, but like for example, you could find right for you know, for age 18, we could get the population where people get the vaccination, right? So for example, 50%, 80%, like people get vaccination over the time, right? Okay, and then you could get a distribution of like the people, okay, and over the time, right? Okay, understand? But anyway, we can talk about that later, right? So you understand, right? Good. Okay, now you may say, hey, look, why one is so high, one is so low, right? Okay, and the reason is what? Let me show you. I show you because we have the physical meaning of the distribution. Okay, let me write down here. This is very important. Look, the probability density, right? Function. This is the probability density function. Okay, the blue color one, right? Okay, and then I'll tell you. Look, and we could use this to determine the probability for x. For example, this x. Okay, this x. Okay, and in the range of, for example, I just say the range from mu minus sigma and to the mu plus sigma, right? Mu minus sigma and mu plus sigma, right? Equal to what? Equal to the area under the curve, right? And in the range of mu minus sigma and mu plus sigma, right? Okay, look here, just the area under the curve, right? From here, from mu minus sigma, right, to mu plus sigma. Understand? Okay, so look here. So this figures the meaning, right? So for example, if you randomly select a value from the population, and then the probability for the value between mu minus sigma and to mu plus sigma is the area, right, under the curve here. Understand? And if you do the calculation, right, actually, right, you learn that in statistics, right? If you calculate this area, actually, you could what? 68%. Okay, this area is around 68% of the whole population. All the area is 68%, right? So therefore, right here. So for example, if you randomly right do a sampling, and then 68%, you can find the value. The value going to stay between mu minus sigma and mu plus sigma. Understand? Okay. So we call this standard deviation. Oh yeah, this, okay, the range. Okay. Now, if you want to get large range, okay. So how about this? We do mu minus 2 sigma and mu plus 2 sigma. Okay. So and this means what? 95%. Okay. So 95%. Right. And if you sample the data, 95% the value should stay in mu minus 2 sigma and mu plus 2 sigma. Understand? And then if you want to get a higher possibility, right? 99.7%. Okay, this is actually when I do experiment. This is, I think this is, to be honest, we don't use this large range. Okay, 99.7%. The value is stay in mu minus 3 sigma and mu plus 3 sigma. Understand? If you do the random sampling, okay, so 99% the value stay this range. Okay. And now I want to mention in when we do a lot of again, I will show later that right, the testing, right, and analysis. This is very important. 95%. Okay, we saw this is a 95% confidence interval, right? So for example, if you get a distribution, right, from right right, for example, you get this, for example, I had the data for right the 18, the age 18, the group. Okay, for example, I had 22 data files, right? Okay, so we sample we can know how, for example, how the percentage of the age 18 groups, right, had the vaccination, right? And we had 22, right, samples, right? And then we get a distribution, right? Okay, and then after that, you just based on the distribution, I will tell you, okay, if we randomly pick a people from the age 18, what is percentage of that people get vaccination? Understand? You could get that from the distribution. Okay, right? Again, I would say you can do that, right, based on the distribution. Okay, and we could do that for your category, right? For example, you get the distribution, right, of the vaccination, right, for your category. For example, education, right? High school student, like college student, you know what I mean? That can tell you information, right? Okay, good. So again, you can use that in your project later, right? Okay, I just let you know now, okay? And we can talk about that later when you do the project. Understand? Now I want to show you the last one quick question I have asked you is, can you, anyone can tell me, right, the area? So the area under the entire curve equal to, right, actually belong negative, positive infinity, and positive infinity. Equal to what?
1.
Very good, right? I can it's equal to 1, right? Right. Look for negative 3 sigma and 3 sigma, you get 99.7%, right? Okay, this means what? You get 100% the value you will get, like for few in this area. Understand? This means equal to 1 because 100%, right, chance, right, the sample, right, has a value between negative, positive infinity and positive infinity, right? Understand? It makes sense, right? Right? Okay, any question on this? Okay, so again, right, when I do a project a lot here, I just maybe highlight, right? You will get the distribution, right, for your categories. right? And then tell the 95%, right? Confident, right? Interval. Okay. So for example, hey, I would like to know, if I get a sample, right? I get a person in the mall, right? In the school, right? 18 years old, and then I could see the chance of that people get vaccination or not. Understand? The probability, right? Okay, good. Any question on this? Okay, now let's just, I want to show you, right? If you want to generate a normal distribution, what command you're going to use? Right here, look, you're going to use the R norm as the command for the normal distribution. Okay, let me just show you. N means what? N means the number of samples, the number of random samples, right? And then mean, this means the mu, right? And standard deviation means sigma, right? So we have specified the mean and sigma, right? Okay, and then this one is, this is the function, right? To generate random numbers for a normal distribution. Okay, right? So again, you could use equal sign here. Use equal sign instead of the, yeah, just use equal sign. And then after that, you want to check your result, you use histogram, right? Histogram X. Understand? Okay. Right. So now let's just check this program, and then after that, we'll move to t-test, right? Okay. Okay, now let's do the normal distribution. Again, I'm gonna put like Control-Shift-C. I'm gonna knock out all these lines here. Okay, and I just gonna type n equal to 200. Again, you don't have to put a semicolon, okay, because it doesn't matter. Mean equal to 130, right? Standard deviation equal to 15. Again, if standard deviation is larger, means that, right, it will spread in a wider range, right? Okay, and then we get S equal to random, right, normal distribution. Okay, and then n, the sample is equal to n. We have 200. We're gonna put the mean value here. Put standard deviation here, right? And after that, we're gonna show the histogram. Okay, good. Right, again, you could use different color. I think it doesn't matter to me. You could also change the S label, Y label, right? Again, after that, you could run. Right, this is what I have, and what you have may look different from me, right? Understand? Okay, because it is random. The numbers, the values random, right? So the more sample you use, and then the more consistent with the result. Understand? Because this it's a random distribution. Okay, understand? And we have issue to get the distribution. Again, your distribution may not look the same as mine, right? Good. Again, you're gonna use this one, right? You use the histogram and to get a distribution for your own data, right? Okay. Good. No issue. No, now let's move on. Okay, now you need to wake up, right? Okay. Now we go to, you want to use t-test. Again, we had a command for the t-test for you, but I do want you to understand what the t-test, okay? So this is a bit challenging. Okay, I think this is the most challenging topic, right? In this project, right? I hope you try to understand. Again, if you don't understand, it's fine. right? Because the background is not that easy to understand. But I hope you still need to know how to use it, right? I could still teach you the program, okay? Understand? I'm gonna show you the example of the program, but at the same time, I will show you, right, the fundamental, for example, equation and derivation, right, for the t-test. Okay. Now I want to show you t-test. So there are three types, two types of t-test here. I will introduce in this course. And the first one is one sample t-test. Okay, it's one single group, right? So now example, right? And so first of all, we have high school 1, right? And then we have high school 2. Okay, so we have 2 high schools, okay? And then, for example, in high school 1, we have 500 students. And high school 2, we have 600 students. Again, I made this up, okay? It doesn't matter, right? So one sample t-test means what? Okay, now the question is, well, all the students going to take our SAT, right? SAT score. They take SAT. So this group take SAT, right? Okay, we say SAT 1 for high school 1. In this group, we have SAT 2. We have this, right? Anyone have already taken SAT or no? Not yet, right? I think some of you already done, right? Again, now it's not required SAT, but okay, but okay. Now let me show you what one sample t-test mean. So for example, hey, one sample t-test means okay. So we assume for high school 1, it doesn't matter. You could do the high school 2, right? We assume that the mean value, you assume the mean value of SAT 1. So the student, right, in high school 1, the mean value is 1,500. Is that high? Is it high, right? Pretty high, right? Okay. So this is the mean value we assume. Okay. So we assume that the high school student, right, get a SAT. The mean value is 1,500, and then I give you 500 samples. Understand? And then you tell me whether the SAT, the mean value actually is equal to 1,500. Understand? This is one sample t-test. So we just want to, we give you the data, and then you tell me whether the mean value of data is equal to 1,500. Understand? Just compare the mean value. Okay. Again, I think we don't use that much in the project, but for example, you could assume that 50% like the population, for example, 18, age 18, okay, 50% of the population should get vaccination, and then you could test whether the data approve your assumption or not, right? Okay, but again, we don't use that because it doesn't tell us too much information, right? Now let's talk about 2 sample t-test. This we call it one sample t-test. Okay, this is one sample. T-test. Okay, now we focus on 2 sample t-tests. Right, these 2. Two sample t-test. Right, what does mean? Okay, so this mean, look. So we had a score, right? High school student 1, so we have 5,000 samples. Okay, and then high school student 2, we have 600 samples. And then my question is, can we assume that the SAT score, the mean value from high school 1 is equal to the SAT score, right? In high school 2. This is called null hypothesis. So the null hypothesis means, hey, the SAT for these two schools are the same, right? Understand? And then we also have alternate hypothesis. First of all, the alternate hypothesis, hey, the null hypothesis is not right. The SAT for these two schools, they are not the same. So how about this? We assume with the alternate hypothesis is SAT, right, in high school 1 is higher than the SAT in high school 2. This we call alternative hypothesis. Understand? Again, the alternative hypothesis can be other, for example, SAT 1 less than SAT 2. Understand? You get higher or lower, it doesn't matter, right? Okay. When you do the t-test, you should tell what is your alternative hypothesis, and then the program can tell you, right? So the program can tell you which one is right. So which one? Understand? Is the null hypothesis right or the alternate hypothesis right? Okay, understand? This is very useful, right? So for example, hey, I have the vaccination data for the age 18 group, and I have the vaccination data for age 40 group, right? And then we could tell whether the vaccination, right, preference are similar between these two groups, right? Or which one is higher? You know what I mean? And this means your conclusion is of statistical significance. Okay, this is not just a random conclusion. This means your conclusion is proved by the data. Understand? That's why we need to do the t-test. Okay, we're not just compare the mean value. We compare the whole population, the whole samples. Understand? Okay. So this we call two independent with two sample t-tests, and this is independent. Independent means what? Means this 500 students and this 600 students, they are not the same. They are not the same, right? Okay. Another one is we call pair t-test. Okay, we don't use this one, but I will just want to show you. Pair t-test means what? Pair t-test means the same group of people, right? Let me just show you. Okay. So for example, right, high school student, right, and we get 500 samples. Okay. And then those high school students, the same group of students, and then they get SAT training. Okay. Right. And then you get sample again, high school student, again, you get 500 samples. Right. And this is before. This after. Right, understand? So in this case, we want to compare, right, the SAT score between these two groups. Actually, they're the same. They are the same students, right? Right? But they have different before and after the training. Understand? Okay. And then we call this as two, just different color. We call this two sample t-test, and then we call their pair. Understand? Okay. So for us actually the sample are in the survey and they may not the same. Okay. All right. So therefore we typically don't use the pair t-test. All right. Understand? Okay, so I hope you had a big picture of t-test, right? One sample t-test and two sample t-test. Understand? Again, we're gonna use the two sample t-test, independent t-test, right, in our project. Understand? Okay. Now let me, any question? Now let me just show example, right? I show you one example for, one sample t-test. Okay. So for example, hey, anyone know Seminara? You don't know, right? But I believe you hear this one from the news, right? Hey, there's some the meat, the beef, the meat get recalled, right? Because Salmonella is detected in the meat, in the beef, right? You see a lot. Salmonella, E. coli, we call their foodborne pathogen. Foodborne pathogens. Okay. Again, it may not kill you, right? But it causes, right, fever, especially for the kids. I don't like that, right? I don't like my kids to get Salmonella, right? Because I had to stay away the meat through the whole night, okay, for several days. Okay, and also we had to treat the kids with the antibiotics, right? It's not good. Okay, so therefore now the study here. Okay, again, after this project, I will say in next year, right? It doesn't matter whether you're senior, a sophomore, right, a junior student. In next year, you could look for internship. Okay, you could look for statistic data analysis internship, right? So this example, look, right? You're working for an ice cream factory, okay? And then look, and then you could do a sample, right? You could detect. Again, this is more about biology, right? I don't want to spend too much time on this. This is means what? Most probable number, right? This number can quantify, okay? This number quantify the amount of Salmonella in the sample, right? In the ice cream. Okay. So now look, so we're gonna for each brand, okay? So we're gonna get all this data, right? I think how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we had 9 measurements, okay? My samples, right? Understand? And then look, and then the key point for FDA, if you want to sell your ice cream, right? The threshold, right, should be less or equal to 0.3, right? So for example, if you have the concentration of the Salmonella per gram is less than 0.3, and then you could sell ice cream, no problem, right? However, if we are larger than 0.3, you can, right? Because you're going to cause infection, understand? And then you are the scientist going to do the work. You should tell, right? For those people, yeah, they just provide a sample to you. It is random, okay? It's a random sample, right? And then it's your job to determine whether this group of ice cream can be sold in the supermarket or not. Understand? So what can we do? What can we do? So therefore now I want to show you again is now from now on it's a bit challenging, okay? The t-test is changing. I want to tell you how the t-test is performed. But again, when you use the command, it's pretty straightforward. Okay, look, I want to show you. Don't feel panic. Right? I show you a lot of detail of t-test. However, when you use it, look, it's that simple. This is the t-test. One line, one command. Okay. So I guarantee you should be able to use the t-test. Okay. But again, you are my student, right? Okay, and especially right in the future, right? Especially if you want to go to a conference, right? And people may ask you the t-test, right? And then that's why I'm going to show you how the t-test actually is performed in the program. Okay, I just not show you the command. If I want to show you the command, 1 minute, 2 minutes, 5 minutes is done, right? But I still want to spend about 30 minutes to explain what's t-test, and then you can understand better. Understand? Okay. So, but again, like maybe let's take a 5-minute break. Okay, like because we're in the middle of the lecture. And then wake up if you're kind of sleeping. Right? Maybe sip a cup of coffee, right? And come back, right? Okay, because I'm gonna teach you the most challenging topics in this training. After this, right, next lecture will be easier, right? And then easier, and then we can do the project. Understand? Okay. So now it's 7:38. Let's come back and 5 minutes. 43. How about that? Okay. Good. So see you. Hi guys, I'm back. Are you there? Great. So I hope you now you're energetic, right? Ready for the challenging? Okay. So Ricky, you're back, right?
Yeah, back.
Great. Okay. Okay, Sarah. Okay, Sarah's back here. Hey Sarah, how are you?
Hi.
Great. So Sarah, I just want to, actually you did not meet. Again, I recorded the lecture for you, but I just want to show you like we're gonna do the t-test. Right. T-test means we're gonna compare. Look here. All right. So for example, we had the data. Again, I would say you watch the video, right? You watch the video for the first half. Okay. And then now what we're gonna do is one to the one sample t-test. T-test means what? Look. So for example, we sample the Salmonella. Right? Salmonella is the foodborne pathogen that cause, for example, infection. Okay. So now we sample the Salmonella from the ice cream. So we had 9 samples. And then for the FDA say if the Salmonella concentration is lower than or equal than 0.3, and then we can still sell the ice cream. Okay. However, if higher than 0.3, so those ice cream cannot be put in a supermarket, right? Okay. So the question here is, how can we use those sample and to make a decision whether this Salmonella are good or not, right? Okay. Understand? So we compare the mean value. We are not just focused on mean value. We use the whole population. Okay. So understand? So this is the problem. And now I just want to show you again. Actually, I show the team, right? I show the team. Hey, for the t-test, it's very simple. The commands very simple here. Look. Okay. But again, I would like to give you more background instead just tell you the command. Understand? Right. So therefore, I just want to show you how the t-test is done in the program. Understand? And this is, as I mentioned, this is the most challenging topic, right? And in this training, okay, right? Okay, now let's start, right? So for example, so before we do the t-test, right, we have to set up the null hypothesis, okay, and then the alternative hypothesis. So the null hypothesis means what? Means means the mean value, right? Mu 0 is the mean value we assume, right? And from the sample equal to 0.3, okay. And then this means, hey, we could still sell the ice cream, right? Okay. And then the alternative hypothesis is, well, unfortunately, right, the mean value is higher than 0.3. Understand? Right? And then your problem here is giving the data. It's your job. Given the data, show, right, and whether we should accept or I'm right here. Okay. Accept or reject, right, the null hypothesis. Understand? If accept, it'd be great, right? But again, right, in addition to you, the FDA also go do the work, okay? So you have to do the right t-test, otherwise, right, we get in trouble, right? Understand? So for example, hey, you're gonna you compare the vaccination, right? Different between different groups, right? You can do similar. Okay. Now let me show you. So before I show you the general procedure, I want to show you for a t-test, we had to calculate t-value. Okay, this is t-value. All right, t-value. Look, I just want to show you S over bar. S over bar is calculated from the data. Okay, equal to the summation of all the data divided by n. N is the number of sample. N is the number of samples. In this case, it's 9 samples, right? Understand? X equal calculate, right? X is here. This is X, right? This is X. Okay. Understand? So this is the mean value calculated, right? From data. Understand? Okay. And then the mu zero. So mu zero, right? Mu zero is, right? Is the mean from the null hypothesis. Okay, right? So we assume that right, the mean value is 0.3. Okay, right? And then the t value can tell you how different the mean value from the data is, right? How different the mean value from the data from the mean value we assume in the null hypothesis, right? Understand? Okay, and then look, right? Again, look. I want to show you two distribution, right? Okay. So this one, the blue color one, right? Maybe how about this? The blue color one. Let me see. Maybe do like this, right? This, right? And then look, this the mean value. This is mean value, right? Okay. And then now let's talk about the green color one. Right? Look, the green color is spread in a large range, okay? Right? And then this one is again this, like this. Okay. So for the blue color one, maybe they are different, right? Okay, you can see, right? But however, in the green color one, maybe they are not that different because they have a lot of overlap, right? Understand? Okay. So therefore, we cannot just depend on the difference of the mean, right? So this is a difference of the mean values. So again, we cannot just take a look of the mean value. Hey, that's because the mean value is so different. So they are different. No, right? We also had to consider what? The standard deviation. Right, understand? So therefore, when you compare the value, right? You cannot just compare the mean value. Understand? So we also have to consider the standard deviation, right? That's why we had to consider the whole population, the whole distribution, right? When we do the t-test, okay? Again, when you do the t-test, it's not just compare the mean value, okay? I just want to say that again, it's not that simple, right? Okay, so therefore, look, that's why we normalize. Look, that's why we normalize the t value using this, we call x. S is the standard deviation. Understand? Right? Okay. So I hope you understand this, right? And the S, again, the N is right, is number of sample. S is calculated by this approach. Okay, this is how S is calculated. Understand? Again, you have the data, right? You get the calculate mean value, and then you you come add them together, right? The difference between each data point with the mean value and divided by n minus 1. Okay, understand? And you may ask me why we divide the summation by n minus 1. Why not? Good question is why not just divide by n? Okay, right? Why not just divide by n? And here's the evidence. Okay, look. So this is the samples, right? So if the sample, 2 sample, 4 sample, 6 sample, if we increase the number of samples, right? Okay, so this is the variance. This square, this is actually it's S square, right? Okay, this S square, and calculated. This S square calculated by the equation, right? Over one, right? Okay, I just ignore all the term here. This is calculated by this equation. Okay, by divided by n, and this one is calculated by the equation n minus 1. Okay, understand? This square I forgot. Okay, and then the dashed line, is the true value. Okay, this is the true value. True S square, right? True S square, right? Understand? Okay. Again, if people ask you this question, right? And then you see why we use n minus 1 instead of n, because look here. Because look here. There's a difference between the true value and then the calculation, right? Understand? Understand? So right here. So right here. So BIOS, and we see the BIOS for small number of samples, right? If the equation is used, right? If the equation 1 over n Si minus S over bar square, right, is used. Understand? Okay. Good. So now I just show you how to calculate t-value. Look, so the t-value is very important, right? Because the t-value can tell you the difference between the mean value and then the assumption, right? Yeah, the like the hypothesis size, right? Yeah, and mean value, right? Okay. Understand? Okay. Now, any questions so far? Okay. Now let me just show you. Right. Okay. We can do this later. Okay. We can do this later. And it doesn't matter. All right. So for example, we calculate the mean value, the t-value equal to 2.2. Right. This calculate. You calculate the mean value, the t-value. This t-value. We can do that later. Okay. Okay. Now, after we calculate the t-value, can we just use the t-value to tell, right? Can we just use the t-value, right? Can we? The question is how to use the t-value to determine which hypothesis is right. Okay. Right. Okay. Now, again, we're gonna have t-table, right? We call t-distribution. Okay. T-table. Okay. Again, you don't see this table in R because R does this for you. Understand? Understand? Okay. So we call this a t-table, and then we call this t distribution. Okay, this t distribution, right? So now, for example, we calculate t value. We calculate t value equal to 2.2, right? So how can we use this table? Okay, right? So look, the first step here, again, it's changing, right? Okay, right? But I do want to show you, right? So step 1, again, to do the t-test, you could do that by hand, okay? But again, you're going to use the program. I will show later. Step 1. Step 1. Calculate the t-value. Okay, so we are done. Okay, this equation, and then this is the program you could use, right, to calculate t-value. Again, the R program actually calculate the t-value for you. Okay, automatically. Okay, and now step 2. Step 2. We calculate degree freedom. So step 2. Calculate the degree of freedom. Again, this is very challenging to understand, okay? But I still want to show you, okay? So degree freedom means what? Look here. So we have 9 samples, okay? So, and then the degree freedom is n minus 1. You might ask me why n minus 1, right? Let me show you. Okay? Let me show you. So what does it mean? All right. So if 8 of the 9 samples, right, are known, okay, and the S over the mean value, because you can calculate the mean value, right? Because you calculate mean value, right? The mean value equal to, right, equal to, right, the sum of all the sample divided by n, right? So for example, if 8 of the 9 samples are known, and then the mean value actually is also known, right? Okay, and we can calculate the 9 sample. Understand? Right? So if we know the mean value, right, we know 8 of the 9 samples, and then the last sample you calculate, right? Understand? So what this means is there's a relationship between them. So this means there is a relationship between them. Okay, and then we call this one, right? We call this as constraint. Okay, this relationship we call is constraint. Okay, a constraint. So something is not free anymore. Understand? Okay, so that's why we minus 1 here. So we have degree freedom is 8, right? Because there's a relationship between the nice sample and then the mean value, right? Okay. Again, I tell you, right, when you use the R can calculate the degree freedom for you. You don't need to calculate it, okay? Let me just slide on here. In this project, you don't have to calculate the R degree freedom, okay? And then in some case, you don't have to talk about too much the degree freedom because, right, because it's very complicated, okay? This is very complicated, especially for the 2 sample t-test, right? So for example, degree of freedom sometimes can be non-integral value, okay? Because the relationship is very complicated, right? Okay. But again, I'm going to calculate the degree of freedom for you, right? Again, when we do the t-test, you don't have to take a look right of the degree of freedom, right? What you need to take a look at is the p-value. I've talked about p-value very soon, okay? Understand? Okay. So this step 2. So step 2 is degree of freedom here. Look. So step 2. So we're done. This from step 2. Again, right? I know it's changing. Let's try to understand, right? Okay. So step 2, we calculate degree of freedom. Look. Now we know degree of freedom here. So this is the t distribution we're going to use. Okay. So look, the distribution, look, the shape of the distribution, right, depends on degree of freedom. Okay, but again, right, the algorithm can show you how to calculate degree of freedom, right? Okay. Okay, now look, so we know the degree of freedom, right? And then we know the t-value. T-value equal to what? 2.2, right? So the t-value x equal to here, in this range. This 2.2, right? So one step closer. So we have all this information. We have 2.2, and we have degree of freedom. This is a distribution, right? This is a distribution. And at the same time, look, because this one tail, I'll tell you what this means. This is the p-value. Okay, this is the p-value. And then, based on this table, right? Because you know the t-value, and then based on that, you could calculate. You could know. Look, you could know the p-value. Right, and then you make decision. That's why you make decision. How to make the decision, which one's right. Understand? Understand? Okay, so you look, you get the t-value, and then based on the table, and then you get the p-value. The p-value between 0.5 and 0.05 and 0.025, and based on that, you can make decision whether which hypothesis is right or not. Right? Understand? Now, you may ask me, what's p-value? Okay. Anyone know p-value? I think maybe Kevin, you know, right? Some of you know. So p-value, look here. Okay. I explain the p-value to you. Okay. So look, this is distribution, right? And then the middle one actually the middle one means the mu 0 equal to x0, s over bound, right? Means the s over bound equal to mu 0. Understand? This mu 0, right? Okay, for example, this is the t-value. This is the t-value, right? Or 0 means the calculated t-value. Right? And now I want to show you what's p-value. P-value is what? P-value is the shape under the curve, right? From the t-value, okay? This is the p-value, okay? So this is the p-value. So this is the p-value. So the p-value, and look, the area for t larger than the t observed. T observed is the calculated t-value, and under the curve, under right the curve, is p-value. Understand? Okay, now you tell me, if the t-value, look, is the t-value close to the middle, right? And then this means what? Means the mean value is close to the, right? This means, so if, right, t-value close to 0, right? This in the middle is 0, okay? Close to 0. And this means, right, x is very close to the mu 0, right? Understand? And then this means what? The null hypothesis means the null hypothesis has a higher chance to be right, right? It makes sense, right? Right? And in this case, the p-value becomes larger or smaller. When the t-value close to the, right, to the middle, the p-value is larger or smaller. The area under the curve, what is larger, right? Because this is the area under the curve, right? So the area under the curve is larger. Means the p-value is larger. Understand? Right? So therefore, look. So if the p-value is larger, means, right, the t-value is close to the middle, and that means the null hypothesis is right. Understand? Understand? Okay. So I just want to explain right down here. Again, I explained a lot, but the key point here is right down here. The p-value. So the p-value, right? You could say is the probability of the null hypothesis. Is true, right? It's right. Understand? So if p-value larger, means the null hypothesis had a higher chance to be right. Understand? Okay. So, and typically, right? Typically, right? When we do the hypothesis, right? Testing, and we want to know, hey, under what condition, what is the critical value? What is the critical p-value for null hypothesis is right, right? For, right, to claim the null hypothesis is right. Okay. Maybe right, it's right. Maybe it's false. Right. It's easier. Right. So to reject the null hypothesis, right, say the null hypothesis is false. The p-value should be what? Should be small, right? Right? Understand? Because the p-value is the probability for the hypothesis is right. Right? If p-value is higher, and then the hypothesis is higher chance for right, right? Understand? So if the p-value is small, means the hypothesis has a lower chance to be right. So what is the p-value we should use to say the hypothesis is right or it's false? So typically, look here, the key point. Look here. This is typically the p-value. So if p less than or equal, maybe sometimes equal to 0.05, and then null hypothesis is rejected. Okay. On the other hand, it's p-value higher than 0.05, and then null hypothesis is accepted. Understand? So if the p-value is higher than 0.05, right, means there's around 5%. Actually, it's not too high, but the hypothesis is high. The null hypothesis is right, and then we still accept the null hypothesis. Understand? Okay. Understand? So this is the key point. Look here, right on. Right. So here we call the critical. Right. So if p-value less than or equal than 0.05, and then gonna reject the null hypothesis. The null hypothesis, right? Because look, the null hypothesis is what? It's mu as over bar equal to mu 0, right? This is a null hypothesis, right? And then the p-value is, look, if the p-value is less than 0.5, and then the p-value, right, less than 0.5 means it's far away from the null hypothesis, right? Understand? Understand? Right? You understand, right? Okay. So this keep on. Look here, because this is 95% confidence. Okay. And look, we use a p-value, or we can also say alpha, right? Alpha, right? We call it significant level. It's 0.05. Okay. Understand? Some people use 0.01, some people use 0.5, but 0.05 is the standard. This is the standard. Right? When we do our project, we use p-value with 0.5. Understand? So p-value is set to 0.05 in the project. Understand? Okay. Any question on this? Okay, so when you do the t-test, look, what you're gonna do is you look when you do the t-test, the R can calculate you the t-value, the R going to calculate the degree of freedom, the R going to calculate the p-value. Okay, and then based on the p-value, you're gonna reject the null hypothesis. Okay, right? Okay, because it's not equal to 0.3. Okay, right? Understand? And I will show you later. Okay, now let me show you. This we call, look, this we call one-tail t-test. One-tail, right? Okay, and then in some case you could say two tails. Okay, two tail means what? Means S over bar larger than mu 0, or S over bar less than mu 0. So this one tail, this we call tail 1, and this is tail 2, right? Okay, so this we call this two tail t-test again, right? And typically we just use one tail t-test. Okay, but I do want to show you, right? So look, right, let me lie down here. Look, because we have two tails t-test, so the p-value actually is what? It's double, right? So the area 1 and plus area 2, right? Understand? So the p-value is double, right? Right? So the p-value of 2 12 test equal the p-value of 1 12 test, right? Right, understand, right? Because you have two areas here, right? This is one area, p-value, this is another p-value, right? Understand? You have double, right? So therefore, for this case, you could use 0.01, right? Right, if for the to reject the null hypothesis, right? Because it times 2, right? But anyway, we typically we don't do the two tail sample. We just do one tail sample. Understand? Okay. Again, it's changing, right? So therefore, look here. So based on the p-value, look, we're going to look, right? The p-value is between 0.05 and 0.025 and 0.05. So therefore, the p-value is small, right? So therefore, we're going to reject the null hypothesis. Means they are not. Means the mean value is not equal to 0.03. Understand? Okay. Now let me show you the sample right up here. Okay. Now look. This program means we're going to manually, right? So we manual calculation of t-test. So after you get a t-test, remember after you get t-test, you use the table, right? You get degree freedom, right? And then this step 3, right? Step 3, you calculate t-test, right? It's p-value. So after you calculate p-value, the t-value, and then you calculate degree freedom, and then you calculate p-value here, right? So you could do the t-test by hand using the t-table. Understand? Right? But again, in this project, you don't do the manual. You just use this command. Look here. I want to show you how to do the command. Okay. What you're gonna do is use t-test, right? T.test, t-test. You put the data here. Okay. And then you put the null hypothesis. Okay. So the null hypothesis. So the null hypothesis. This is set by the computer. Okay. The null hypothesis is S over bar equal to mu 0.3, right? Mu is the mu. It's mu 0 equal to 0.3. Okay. Understand? So this is mu 0. The mean value, right? We are set like 0.3. Understand? Okay. And then the alternate hypothesis is what? Is S over bar larger than mu. Right? Understand? So this is mu 0. This means mu 0 equal to 0.3. Understand? Okay. So if you do the two sides t-test, means S over bar larger than mu 0 or S over bar less than mu 0, right? Okay. And then this one is S over bar less than mu 0. Understand? So we do 3 tests. Okay. Understand? And typically when you do a project, you just do one. Okay. Okay. I will show you later. Right. Okay. Now so how about this? Let's type in the program, and if you have a question, you can ask me. Right? How about that? Okay. Again, right? I hope you understand how to do the t-test by hand. However, if you don't understand, it's fine. But I hope you understand how to use the program, right? Okay. Now let's just type in the program. Okay, I select all this line. I click C, Shift C. I block all this line here. Okay. Now let me just type in Seminara salmonella equal to C. So value 0.0. Again, just be careful, right? The value is not that easy to type, right? 0.593, 0.142, 0.329, 0.691, 0.231, 0.793, 0.519, 0.392, 0.418. Okay. Again, you could calculate this, right? The standard deviation. SD cell means standard deviation, right? SD salmonella. Again, I use capital. Okay, you could use the lowercase. Just become consistent. And then you could I can show you the standard deviation. Okay. And then I could calculate the mean value, right? The mean value of salmonella, right? Equal to mean salmonella, right? And then again, I want to show this mean value. Right? Okay. And then now after we calculate the mean value and then the standard deviation, we calculate the t value, right? The t value. So t value equal to, remember, the mean value, right, from the data minus the hypothesized mean value is 0.03, right? Okay, and divided by so remember, right, the standard deviation, right? Standard deviation SD. Okay, I just put the right? Look here. This is how you calculate, right? Go back to the here, right? So divide the standard deviation, and then the standard deviation divided by the square root of the number of sample, right? Right? Okay. So therefore, I just type in here. So therefore, we're going to type in right? So we can type in right, standard deviation, right? SAL divided by the square root SQRT of the n. The n equal to what? The n is equal to the length of a salmonella, right? Anyone still remember what's the length mean?
Number of elements.
Very good, thanks. I am Jason. So if you could actually yeah, let me see. I forgot the parentheses here. So the length here. Okay, I forgot that. Okay, I delete parentheses by mistake. Okay, what's going on my computer? It froze. Okay, let me save it. I don't know what happened to my computer. I hope you don't have this issue. Just froze. Okay. Let me just save it and then restart my computer. How about that? Again, right, you continue, right, typing the programs. Okay. So don't do all the 3 t-tests. Just do the one. Just do the first one. How about that? And then I okay. So I'm gonna go to my folder. And then set this in working directory. Okay. Now there's a typo. I believe there's typo here. Right. And then this is the length of salmonella. Right. So salmonella, this is the n, right? The number of sample and the square root, right? And then this standard deviation divided by the square root of the n, right? So we're done with this t value. I just want to validate, right? I just want to validate that, hey, the t value we calculate is the same as the program provided by R, right? So we do the R alternated, right? Hypothesis equal to, again, you could use the single quotation or double quotation, greater, right? Then mu is now hypothesis, right? Mean value 0.3. Okay, good. Right now, we just do the right t-test, right? We just select this line. Okay, let me right click command window. So I just Control L, right? And then I just click run, right? Okay, look here. The standard deviation is 0.2128, right? And then the mean value is 0.456, right? Okay, and then look, the t value. Actually, I'll show you the t value. Let me just copy the t value. The t value we calculate, right? So if you run it here, the t value. So the t value is equal to, look, this is the t value we calculated, right? Understand? By hand, right? And then this is the t value calculated by R, right? Okay. Again, we don't have to take a look at degree freedom because the degree freedom is used to determine the distribution, right? Okay. And then the p value, look here. P value, look. So p value is less than what? 0.05, right? Understand? So therefore, which hypothesis is right? The alternative hypothesis, right? Right? Right, understand? Okay. So let me write down here. Because again, the p-value is small, but p-value less than 0.05. So we're going to reject the null hypothesis. So this means, look, the alternative hypothesis is right. Okay. Alternative hypothesis is right. And then the program does show you, look, alternate hypothesis. Okay. The true mean value actually is greater than 0.03. Understand? So this one is right. Understand? Right? So therefore, based on the data, based on the t-test, we can, unfortunately, right? The ice cream cannot be shown on the supermarket. Understand? Again, right? Again, you could do that in your project, but typically we don't use two right, one sample t-test. Right? Okay. Right? Any question? Anyone have issue to get the result? Anyone okay?
I got the p-value as 0.9707.
Yeah, I think you calculate that as for the less, it's not the greater, right? Okay, let me
How do
let me
I
show you.
calculate it for the grade? Okay.
Yeah, so look, so Ricky, right? I think you run too fast. Okay, we just focus on the first t-test yet. Right? If you just run the first one, the greater, right? So you get 0.0293. Right?
Okay, I got
Got
it.
it?
Mhm.
Got it? And then actually, if you do the last, actually is you add them together into one. Okay, you could get a last. Right, the less is opposite of the greater. Okay, less means, look here, right? Means it's 0.93, right? 0.9307, and then this also means that the less is not right. All right, okay. But again, it doesn't mean that the null hypothesis is right because the p-value is still large, right? Okay, look here. If we add them together, it's equal to 1. Understand? Understand? Okay. So therefore, when you do the t-test, you just do one tail, right? You do the, for example, if we do the greater, right, is less than 0.05, and that means the greater is right. However, it's very close to 1, and then means the opposite is right, right? However, it's not close to 1, it's not close to 0.05, and then means either of them is right. The null hypothesis is right, right? Understand? Because the p-value is large. Understand? Okay. Good. Right, let me write down here. Right. So these two are the last. Typically, you just try to use greater, right? And just try to see the p-value. If the p-value close to 1 or close to 0.015, and then you will see, right? And if it close to 1, means the opposite is right. Okay, means the opposite is right. For example, it's greater means the less is right. Okay, so if it close to 0.05 means the alternate is right. Okay, for example, we have greater means the greater is right. Understand? Okay, so you just need to do one tail. All right, but if it's not either close to 1 or 0.05 means neither greater or less is right. Okay, it's the null hypothesis is right. Understand? Okay. Again, you just try and error. Again, it's not too many hypotheses for you to track, all right? So it should not take you too much time. Understand? Okay. Any question about the one sample t-test? Okay. Again, we don't use one sample t-test too much, so right. So therefore, let's move on. Let's move to the two sample t-test. Okay, this more. Right. This is the one we're gonna use. Okay. Two sample t-test. Okay. Right. Again, when you do your project, for example, you want to compare the vaccination, right? For example, data between the age 18 or age 40, whether they are different or not, right? That is the two sample t-test. Understand? It's their independent two sample t-test. Understand? Right? Okay. So therefore, I want to show you. Look. Right. Again, we mainly compare the means of two independent samples. Right. Again, we could use this data. So the control group. Right. Now we're going to compare the mean, the math score of the male students, and then right the math score of the female student. Right. So look, the question is, if the male student, the mean value, and then the math score of the female, right? So the null hypothesis is, look, the null hypothesis is, maybe I use the math, it's maybe easier. The math score of the male is equal to the math score of female. Okay. Again, the null hypothesis is always equal, right? Because it's, remember, it's in the middle, right? Equal is the 0 in the middle, right? Okay, it's the peak value in the t-test, right? The distribution. Okay, so always this happen, right? And now hypothesis is equal, and then now let's do the alternative hypothesis. Okay, again, I don't say I don't say the right. For example, the male students are not as smart as the female, right? Just hypothesis. Okay. Okay, now how about this? Let's give a little bit more credit to the female student, right? So look, hey, let's say the alternative hypothesis, the male students score, the mean value is less than the female. Understand? Okay, now you have the data. Look, so you have the data mass, right? And then you also have the gender. Understand? Okay, so therefore we're going to do the two sample t-test, right? This is always is a two sample t-test, right? Okay, again, you're going to use this a lot in your term project, right? Okay, in your team project. Okay, now again, because I already covered the one sample t-test to you, so I don't want to spend a lot of time to explain two sample t-test, which is much more complicated, right? So, but I do want to show you how to calculate the t-value, right? So t-value, look. Again, I don't cover the detail, but I do want to show you how to calculate t-value. So this is the t value, right? For two sample t-test, right? This again, this is the mass value you calculate from the data for the male, and then this is the mass score you calculate from female, right? Understand? And then SP is what? SP is the right, is the pool standard deviation, okay? The pool standard deviation. Understand? Right? And this means what? You calculate this is the standard deviation for the male, and then you get the standard deviation for female. Actually, it's the variance, okay? X square, right? This for female. Actually, this is variance, okay? But again, it's the square of the standard deviation, and then you add them together and divide by 2, and you get a square root, okay? Okay. But anyway, again, this is how we calculate after you calculate the pool standard deviation, and then you calculate the t value, right? Okay, and after that you get the t table, right? And they get the p value, right? Okay, all of this again. Okay, again I skip it, right? Okay. Now I just want to show you how to use program. Look, this program. Look, to do a t-test, two sample t-test. Okay, the key point here is the data for male students. Right? And then this is the data for female students. Right? And then an alternate hypothesis means what? Less means what? Less means the first one means the mass. I use different color. The less mean the first. Look, be very careful. The less means the first item less than the second item, right? The first item is male, mass M, and then less than the mass female. This means less, okay? Less means the first one less than the second one. If you use greater, means the first one greater than the second one. Understand? Okay. So the key point is in your project. Yeah, in your project again, I will write here. I use the triangle here, means something you could use in your project, right? The blue color triangle, right? Again, right? For this one, you need to be very careful. You need to set the data. For example, for me, right? The vaccination data for age 18, vaccination data for age 40, right? Maybe less than, something like that, right? Understand? Okay. Now, how can we get the data for the male and female? Look here. So get the student for the males, and then you need to find which sample for male students, right? Okay. And similarly, look, this which sample, right? The sample for female. Understand? So how can we get the index for the male? Look here. Look. So this is the sample for male, right? Because look. Because for each student we have what? We have a gender, right? Okay. So if the gender equal to males, and then we can get all those samples. But if the gender equal to females, we get all the samples, right? Okay. This means the indexes of samples for male students. Understand? Right? And then similarly for the female, we got the samples, we get the indexes, right? Okay. Now let's run the program. Right? Let's run the program and then you could understand much better. How about that? Okay, again, so make sure that, right, especially like if you turn off your R, right, you restart your R, you have to set the folder, right, have the data and that had the data and into as your working directory, right? Understand? Okay, now let's tie the program together. Okay, now again, I just knock out all this, right? Control Shift C, right? And then I knock out all these commands. Now let me just show you. Again, we get student. Again, you could, I think we could copy, right, from the previous example. Let me just copy. How about that? Student, just say space. Okay, I don't have my program. Okay, okay. Let me just type in. Right, I just want to say space, but okay. Student equal. Again, I use all. I just use equal from now on here. Right, it's equal. Okay. Right, read table. Right, student. Right, student info. CSV. Again, right, this header equal to true. You could put T here and separate equal to comma, right? Okay, good. So this data. Okay, how about this? Let's just type. Let's just see the data first, like before we move on, right? And then put students, right? Okay. Let's run the program first and make sure that you get the data, right? How about that? Let me control L, create a command window, and then we just run the program. Look, I get the data, right? You get the data? Make sure you get the data, right, before we move on, okay? And when you should get the data, because we got this before, right? Okay, good. Now let's look here, right? And we could get her. Look for the female, for the male. Look for the male. We get index as what? It's 1, right? Sample 1, sample 3, sample 6, 7, and 8, and 10, right? Understand? Okay. Now let's just do it, right? Index, right? Male equal, which means what? Okay, which is very important, right? Okay, I forgot to mention, right? Which is a very important, right? Command we use. So which, right, returns the sample indexes, right? Meeting the requirements, right? Meeting the condition, right? The condition. So the condition you specify here, right? This is the condition. Student gender equal to male, right? Okay. Understand? So which is very important. All right. You could use the which a lot, right? For example, in the future when you do the project, you put a condition there, and then you use which, and then you find all the samples. Okay. Okay. Let me just type in. Okay. So one thing, be very careful, right? The gender, there's a typo. So I use GANDE. Okay. Be very careful. So there's a typo in my Excel file. So student, right? Student. Again, you put a $sign here. Look, this gender, okay? Right? It's not GENDER, it's GANDER, right? Understand? I'm sorry, right? But again, you don't need to type in, right? When you put a $sign, the name will come out automatically, right? Understand? So this equal to male, Okay, so this index, for example, I want to show you the index of male students. All right, let me just run it. Okay, okay. Look, let me clear command. Let me just run it. Look here, right? It's 1. Look, 1, 3, 6, 7, 8, and 10. Right? You got it? Right? Anyone have issue to get the index? Very good. Okay. Now let's move to the second one, right? For the female students. Okay. Now let's get to the female students, right? So again, index and female. Again, which students? Okay. And then use dollar sign, gender equal female F, right? And then I put index female F right here. Okay, I just double check my result first, right? Double check. Okay, run it. Look, so we have 4 female students. It's 2, right? 4, 5, and 9, right? Okay, good. Okay, now after we get the index of the student, and now we could get a math score for the student, right? Okay, so we get a math for the male, right, equal student, and then we just focus on math. So let's put math here. Be very careful, right? Now we use the square parentheses, okay? Square parentheses, okay? Because the square parentheses can tell you which index, right? Which sample we should use, right? Understand? Understand? So for example, for the female, for the male, we just put index of male, right? And we just tell the student, tell the program, we're gonna get those samples, right? Understand? Okay, for the male student, right? Or if you don't trust me, let me just show you the result, right? Male, okay. Let's just show result. How about that? Look, run it. Right, the male student, look, the score is been 90, right? 59, right? 83, 67, 72, and 74. Understand? Got it? Okay. Now similarly, right? You just copy and paste, right? Again, be very careful. Copy and paste, okay? And change M to F, right? Change to F. This to be F, right? This will be F. Again, when you do the project, be very careful. You need to check. You need to check the data before you do the t-test, right? Understand? Okay. So you select all of these 2 lines, and then you run. Look, right? This is for the female, right? Female score, right? Okay. So therefore now we're going to do the t-test now. So now we do the t-test. So t-test, right? Mass, male, mass, female, alternated, right? Equal, less. Got it? Okay. Now we select this one. Okay. Again, let me clear command window. Control L. Select it. Right. Look. It's 0.1136, right? Okay. It's not close to 1. It's not close to 0.01. 0.05, right? Okay. So if you want to try, for example, hey, let's do the greater, right? If you don't trust me, let's do greater. Right? And then I'm gonna result. So the greater actually, I say it's 1 minus 0.01136, right? You get here. This add them together equal to 1, right? So look, either one is neither one is less than 0.05, right? Understand? Then this means the man's math score is not greater or not less than female, right? And because the p-value is larger than 0.05, right? For both cases, right? Okay. So therefore, we're gonna accept the null hypothesis. Okay. So we're gonna accept. Write down here. So the p-value. So the p-value larger than 0.05 and 1 minus 0.01136, which is for, right, for greater, right? For greater. Right, and this equal to 0.08864 is also larger than 0.05. Understand? So neither of them is right. Okay, right? Understand? This means what? Means we can not reject the null hypothesis. So therefore, we had to accept the null. So we had to accept the null hypothesis. So we had to accept it. This means what? Means the math score of the male student actually similar, right? And to the math score. Again, the mean value. Okay, we had to focus on the mean value, right? Of female. Understand? Okay, so this means there's not that difference between the female and male, right? Okay, the mean value. Okay, we compare the mean, not just the highest one, the lowest one. Understand? Anyone get a similar result or have issue? Okay, so so we have 4 minutes to go. We have 4 minutes to go, right? And I think we don't have time. We don't have time to finish this one. But again, I think this one is very similar to the one I just showed you, right? So therefore, I'm not going to do this one with you together. You could do that after class, right? Understand? So the difference between these two is here. Look, for this one, we only consider the gender, the male and the female, right? In this one, look, anyone can tell me what this means? This means what?
It's looking for male students that have a math score of greater than or equal to 70.
Very good. Thanks, Kevin. So this means the male student. Again, first is male student. All right, and then with the mass equal or higher than 70. All right. So similarly here, this means the female, right? Student with the math score higher or equal than 70, right? So look, so we will narrow down the population, right? The groups, right? And then look here, we compare what? We compare the physics score, right? Understand? So what we assume, hey, look, we assume the alternate hypothesis what is the physics score of the male student with the math higher than 870 should be what? Less than the physics score of the female student at the same time with the math score higher than 70. Understand? Okay. So this is, I just want to show you multiple conditions, right? But the program is very similar to the one I just showed you, right? We just add one more condition, right? Understand? Any question on this? I believe we can do it by ourselves, right? Okay. Any question? Okay, now the result you should set here. Look. So the p-value is so small, less than 0.05. So unfortunately, right? Unfortunately, in this case, well, this is right. Right? So the null hypothesis is right. Okay. Understand? Understand? So means the female, right, student, if the female student had a score higher than have a math score higher than 70, and then that female student may have, but those groups female student may have a higher average score in physics, right, than a male student with the math score higher than 70. Understand? Understand? Again, in your project, you might not need to use multiple condition. I just want to show you, right? This is a program, right? If you want to use it, this is the program you're going to use it. Okay, good. Any question? No question? Okay, so in the next lecture, I will show you this one. This one I think the most important you're going to use in the term project. So in next lecture, please come to the class in time. And at the same time, in the next class, I'm going to show you which category of data you're going to handle. And then I will show you how to extract the data, right? Understand? So please come to the class in time in next class. Understand? So tomorrow is the, right? Tomorrow is Friday, right? And am I going to watch the NBA today? It's the game 6, right? Okay. So my kids, they're waiting for me outside now. So I had to go. Okay. If you have a question, you could email me. Or you come here tomorrow a little bit early. Okay.
Thank you.
Otherwise, we're done today. Okay. Bye bye.